All right. Welcome everybody to today's Build Your Composite Simulation IQ webinar. Just do a quick test here. Can everybody hear on the call? If you can't hear, you probably don't know I'm asking this question, but Marwan, are you there?
Yeah, I'm here and I can hear you. Hello everyone and welcome to today's webinar.
Awesome. So once again, it's Marwan and myself. Been hammering away at the webinar series over the last month, doing some simulation mechanical and some composites information. So we're glad to see everyone again this week. And today we're going to be covering some information related to Helius PFA, and that's our progressive failure analysis tool that we use for composites. I'll get more into that later. We'll cover some basic stuff for this week. Today, what we've got in the news, we do have an update for Helius PFA, so anyone that's using that can check for the update. I've included a link here where you can go and check that out. I'd also suggest for everyone that's looking to do the upgrades to use the application manager, and I'll cover that a little bit. That's the advised method, but if you do have any issues running through that, certainly don't struggle with it. Just reach out to us in support and we'll get you a download file. We also have some Helius Composite updates that have come out. So if you've installed Helius Composite 2016, there are some updates for that. Address some stability issues as well as a few bug fixes along the way. And then lastly, we have the schedule a call functionality, and that is new to Autodesk support. We'll go over a little bit about the application manager today, some of the related items, and then Helius PFA, just kind of a getting started. A very basic webinar today. We're just going to be covering kind of the common issues that people encounter when getting started. Either creating a new analysis from scratch or converting an existing analysis to use the Helius PFA functionality. All right, and if you're not familiar, Autodesk Application Manager is something you can use for updating your products. Not all the products use the Application Manager. Simulation Mechanical is one of those that does not. But the Helius products you can install. Once you have them installed, it'll check for updates and alert you when you need to do download and install of various things. Here on the image you can see one of them for Helius Composite 2016. That's a hotfix 1, and it gives you a little information about when it came out, how big the file is, and kind of how we view the severity, so you can take the information and determine if you want to do the update. So that's found in the tray icons on the lower right, down by your clock on your desktop. So you can expand that out and open it up, and that's all I have for that. Marwan, do you have anything to add for the application manager?
No, not for the application manager. I just wanted to elaborate a little bit about the schedule a call. That's a new offering that we have in our tech support department, where you go in and request that we call you back at a set time to discuss your tech support questions. There is a detailed description on how that feature works, or that offering works, on our simulation mechanical forum. And it's not particularly simulation mechanical, it's any, in this case, simulation product that you can request a call. But if you just go to the forum, there's a posting on the top there that describes how you can go in and schedule that call.
Yeah, this is a great new thing that we rolled out just this month. So if you haven't contacted support in a while, it may be something that's new to you, but the focus there is that you get to choose a time that's convenient for you, and we'll call you back. And like Marwan mentioned, We've posted information in all the product forums, so if there's a product you commonly use, you can go there, check out the schedule, a call post, and it gives you a step-by-step walkthrough how to use that functionality for installation and configuration and product-specific questions. So other areas, there's chat functionality and I believe email. So if you're looking for the schedule a call, it will be for those two functions there. And of course, down at the bottom, you'll be able to download the PDF for today's presentation along with any files that we go through. So that's autodesk.box.com/getting-started-PFA. All right, so today we're going to cover some of the basic issues that people kind of run into when they're getting started, setting up their analysis or reconfiguring an existing analysis to use the Helius PFA user subroutine. So for those of you that aren't familiar with Helius PFA, it is a plugin from Autodesk, and it's used in conjunction with FEA structural programs like Abacus and Ansys. And we use the user subroutine is called to identify failure at the constituent level of composite, so the matrix and the fiber stresses and strains. We determine when those have failed, we degrade the properties accordingly and allow for that progressive damage to be seen. So I think everybody's probably kind of familiar with the general workflow, but if you're not, feel free to post a question down in the comments for the chat, and we'll get to them. Some of the basic things that people run into, I want to highlight the learning paths that we have on our online documentation. That's something that's relatively new within the past few months. Our learning experience team has built this nice forum, so you can go and just click on getting started, click on the platform that you're using, and it'll walk you through the general overview and then gradually break you into more detail as you need to go along. So that's a great new tool that they've come up with. Next is creating a new material. That's something a lot of users bump into, so we have some information on the website about how to do that. Setting up the analysis, so you can take an existing analysis. So if you're familiar with Abacus or Ansys, you can take that existing file and modify it either manually or through the GUI to use our user materials and our controls. So I'll walk a little bit through that today, just because that's very common for people to overlook. And then interpreting the results is an issue that a lot of people get frustrated with. We have a lot of documentation on that, so I advise everybody to check it out. And then lastly, we have a user quick start guide that's really useful for people. Even if you're an advanced user, a lot of this information is for basic users, but even advanced users kind of glaze through and skip from the beginning to the end and then run into an issue because they miss something along the way. So I advise everybody to read through that user quick start guide, and it just highlights some things that you need to do. And then along in the documentation, we have example problems. These are for more of the advanced users that may be looking for a solution to a specific problem. We have the operations guide, which includes information related to installation, file requirements, operating system requirements. Anything else, Marwan, in there?
No, not that I can think of. One thing maybe I thought when you're mentioning the steps, Dean, is when you said you can go in and change the input file through the GUI. Now, is that the Helios GUI or let's say the Abacus or ANSYS GUI?
All the changes can be done through, say, the Abacus or ANSYS GUI.
Mm-hmm.
If you do have an existing, say for Abacus, you have the input file or the INP file, we do have some instructions so you can just modify that via a text editor, which is a really simple way. You know, if you already have the input structure, you can just go in and replace a few sections. And I have some examples. We can open those up, and I'll actually just give a quick overview on that. So, yeah, great question. And then, so that's the operations guide. That's kind of basic. Licensing information. If you have questions about that, that's a good place to look. And then, lastly, we have the theory manual. It's very in-depth. It covers a lot of the nomenclature that's used, criterion, some of the theory behind why we're doing certain things. So I advise you, if you're really interested in how things are working, that all the functionality that we have is very well documented for the Helius PFA product. So I'll have a link for that at the very end. So when we send this PDF out to everybody, you can have a quick reference for everything. And let's go ahead and open up some text files, and I'll walk through some of the basic information for just how to get started. And close this. And I'm just opening up an input file here in a text editor. And so here I have a Abacus input file, and we can see some basic information. Last month I covered a lot of troubleshooting information, so that that might be something good to watch. We cover a lot of the structure for the Abacus working directory. So some of the things that I may mention today, if you go back and review that last webinar, that might be a great starting reference point for you to understand how this all fits together and the structure. So we have a heading up here. This isn't always required, but it just gives a little information about what version of Abacus was used to create it. We have the part definition, and when you're getting started, a lot of this can be left alone, but the primary thing we need to identify is the material. When Abacus is going through and it's reading all these keywords, it gets to the star material keyword, and normally you can have it just defined as a star elastic material. That information is inputted directly through the Abacus GUI. It has all the parameters listed here. You can look in the documentation and actually look at this keyword, and it'll give you all the information you need on how that's defined. So in order to use Helius PFA and use our user material, we have to define the star user material keyword. For example, a typical Abacus material will have the star material, the name of that material, and then star elastic with the stiffness and Poisson ratio here. And we would replace this with the Abacus or the Helius PFA material that we've defined. And this is the name that references the name of that material, and then these star depth var, which is dependent variables, those are defined, and these are all explained in more detail in the documentation. So if you go through the GUI, you select your material just like you're building it as you would through Abacus. These will all get added automatically, but there are instances where you have an existing input, you don't have material that you're developing, and you want to see how that influences the results, so you can quickly change that here just by changing the name. The star user material keyword is what's going to flag our Helius subroutine. So having this here will, as Abacus goes through and is checking things, it will look for our user subroutine. That's when our license gets called, and we proceed down the road. And the user material, the information that's contained in here, these are all parameters. They correspond to specific things like fiber direction, unit sets that we have 4 available unit sets that you can choose from. You can change that right here. You can turn progressive failure on or off. So if you have a large section of your model and you want to turn progressive failure off for that because you're not interested in damage, say it's where you have a set of boundary conditions and there's instances where those boundary conditions can actually cause some inadvertent stresses and failure. You just want to ignore those. That's not of any interest to you. You can turn off progressive failure for that particular section. There's also many other parameters in here for temperature. They're all turned off, for the basic functionality. These two here are fiber and matrix degradation. So when our user subroutine identifies that there's damage in either the fiber or the matrix, we specify how much we want to degrade those stiffness properties by. That's controlled right here. So if you want to change those parameters and see how it influences the results, you can do it easily. And when you're doing this, we add the star material keyword and we change the material name. One of the things that you have to go and do is identify the section. So here we have just one ply in this solid section. We would have to go in here and update this material name to reference that material that we added. And that's about it as far as adding the material. Relatively simple, but it's one of those things that if you're not familiar with using Helius PFA, we run into it time and time again for either people that are just getting started or maybe they don't use Helius PFA every day or they're not using Abacus every day. You lose it after a few months and then you jump back in and just get right to the end, and then you realize you've missed a lot of the setup procedures. So the next thing we want to do is set up our controls. And if we go down here into the step section, this is where all the loading and boundary conditions are defined, and we can see a keyword here called star controls. And these are all the time incrementation parameters that are used by Abacus. And this section is normally not required for standard Abacus material, but for our user subroutine, in order to take advantage of some of those solution controls that we have, we need to have this in there. If you don't, the analysis it could start, run. If there's damage and it's doing a lot of iterations in that first increment, it'll fail immediately. Or it could, get to the point of the analysis where the damage starts to occur and then it will abort. So it'll usually give you some information in the Abacus output as far as what's going on. But this is a commonly missed one either doing it through the GUI or just directly through this input file. It's not part of the normal Abacus workflow, so it can be missed. So make sure you add that in there. And then lastly, we have some field outputs that are requested specifically for using the Helius PFA user subroutine. And one of these, for example, for this particular model, we've only requested SDV, and it's for this one ply, so there's not much information to request. We can also call stress, strain, or you can call, those are all subsets, and they'll call all the associated parameters for the stress, or you can call out individual, S11, S22. But this SDV parameter for the star element output will call our generated damage criterion, and those are all explained in the user documentation as well. But when you look at the output, this is generated specifically by Helius PFA. So this is what a lot of users are interested in. We show the damage for the model. So we flag elements as either unfailed or blue, red, or green. And so those key users into whether or not the element is unfailed, there's matrix damage, or the fiber has failed inside that element. And that lets you know whether or not that element can carry any load. So pretty useful. Again, something that is commonly missed when people go through and set up their input files. So I'm trying to think here if there's any other parameters that I missed. Is there anything you can think of, Marwan?
No, there's nothing that pops to mind, but just as a summary, so what Dean, you were saying, you added the Abacus or the ANSYS input file, you directed the user-defined material, this way it knows to go into the Helius PFA to grab those, to run the subroutine. Not only are you directing it to the material, there's also a lot of controls in the material that tells it what to do and what not to do. So that's one step. Also, these solution controls is another step. I'm just trying to highlight the general steps. And basically you run it in Abacus, and that's going to do all the communication back and forth with Helius.
And for example, we can walk through the documentation. A lot of people don't realize we have this available. It used to come installed with the software, but now we make it available online. So if you go to our Helius PFA homepage, you'll get a bunch of menu items here, and you can drill down through them. One of interest, what we were just talking about here, is covered in a lot of detail in tutorial 2. This walks the users through exactly how to modify an Abacus input file. So just what we were looking at here is covered in the documentation. It is a slightly different example, but the general workflow is the same. So we'll just click on modifying the output request. We have some videos here that are available, and it covers node output, element output. We can see here that we have the stress, strain, and SDV. It also shows how to identify the section points for each ply. It also, we walk through users through how to create an Abacus file from scratch. And again, there are a few things here that people that are familiar with Abacus just kind of jump over. And the one is that the solution controls, that's a key one. And that one should be, I believe it's here in this analysis step. and it walks through how to do this through the graphical interface. So when you're in there, you'll go to General Solution Controls, Edit, Load Step, and then there's 3 tabs that are in there with all the information. You just go through and add these numbers to the fields, and then click OK. And one thing I forgot to cover, extraneous stiffness parameters. When you're using a standard elastic material that's defined by Abacus, you don't need to calculate these stiffness parameters. Abacus will do this automatically. When you have the user subroutine, it will not know how to read those material inputs, and it will abort. It'll give you an error message that says specifically, stiffness parameter is not able to be found. Sometimes it'll throw warnings if it's not in there. Not all elements require those additional stiffness parameters, but some do. And if you have those in your input file and you run it with the user material, there is an extra step. We provide a program called Xstiff. It's just a command line tool, and it's used to read the input file, calculate those extraneous stiffness parameters using the Abacus criterion, and add those automatically to the input file. What people used to have to do is go through and calculate those themselves. Lots of room for error there, so we provide a handy tool to just automatically do that. So Xstiff is part of the installed Abacus or Helius PFA programs, and I can just pull this up and show it to you real quick. It can be found under the Autodesk menu, under Autodesk Helius PFA, and we'll open up Command Shell. And when you open up this command shell, there's a few things you'll notice right off the bat. It's blue and green. So if you have an issue, you're trying to run Xstiff, a lot of the time we just say, can you send us a picture of the command shell, and this helps us identify the most common problem is if you're using a regular command prompt, a lot of the paths will not be set. So we have this specific command shell that will set all the paths for Xstiff, Material Manager, and some of these other commands that people use. So make sure that when you're running your analyses or running Xstiff, try to use this command shell, and it also makes sure that you're using the appropriate version of Xstiff for Helius PFA 2016 or 2015. We do update all these programs continually, so you can type in Xstiff. It gives you a little information about here how to run it. Commonly, you would just run Xstiff-I and then the name of the input file, and it will go ahead and read that input file, calculate those extraneous stiffness parameters, add those in where they're required, and then it will write out a new input file, and appended to the name will say _XS, and that's how you will identify that the extraneous stiffness parameters have been added. So let me open that up, and I can show what that looks like. So here, for example, we have the partition file. That's the original input file, and then once we've ran it through Xstiff, we can see that we have partition_XS that's been generated. So, and we can open this up in the same way and do a search, and we can see that this hourglass stiffness keyword has been added, and this value has been automatically calculated. And that'll be added to each section that's required. So, really useful. Again, something that people forget. Again, if you launch that analysis, you haven't added those stiffness parameters in there, Abacus will not be able to run through the analysis, and it'll report, and it'll give you some output pertaining to that. So that isn't required. If you're an ANSYS user, you can run through, and ANSYS will go ahead and calculate those on the fly. So let's see what else we got. I think that's all I have for today. If you do have any more questions regarding the specifics to anything that we talked about, setting up a material, creating materials, things like that, we can certainly go over those in more detail in a future webinar. I think each one of those topics carries a lot of weight with it, so probably too much for today. But as a reference here, as we send these out, we'll send out the YouTube link where this is recorded, and we'll also send out the PDF for that. And inside this PDF, you'll have a link to the Quick Start Guide, the videos, tutorials. We have tutorials for all the products, ANSYS and Abacus, walking step by step how to go through setting up different analyses using different methods. So, and then lastly, the theory manual that's available. And do you have anything, Marwan, before we part for the day?
No, I think you pretty much covered everything you set out to do for today's webinar, Dean. That was very informative.
All right, and make sure you check the forums, check out when the upcoming dates are for the webinars. I'm going to pull that up right now, and we'll throw some dates at people. Find my bookmark here. And so this is the simulation mechanical forum, but I just clicked on the bookmark, but you can go browse by product and find all the products here. Here's Helius PFA. There's two main forum boards. The general discussion, if you have questions about composites or anything related to composites, whether or not it's a Helius PFA question, we invite you to throw it on there. I'm on there a bit. Our product manager's on there, as well as our developers, learning experience guys. They all browse those and try to answer questions. If you have any ideas for new features that you'd like to see, or maybe functionality you feel is missing, you can click on this idea station here, post those. Those are mostly reviewed by the product management team and incorporated into ideas for future products. So if there's something you're missing, there is an avenue for you to get your voice heard by the product team. And build your Helius PFA IQ. We do kind of a combined effort for Helius PFA and Helius Composites. So usually you can check the topic for this particular month and kind of see what it pertains to. I think the next one we have tips and troubleshooting for optimizing MCT materials in Helius Composite. And then the next one after that is the what's new in Helius Composite, which may be getting rolled back to a future date. So again, just keep an eye on that if you're interested in Helius Composite, learning more about that program. We'll be covering that in depth over the next few months. So, and that's all I have for today. So I think unless Marwan has anything else, we'll go ahead and let you guys out of class early today.
Yeah, we don't have any questions that came in through GoToMeeting.
So I
All
think,
right.
all right.
Well, Marwan, it was good having you on here. Hoping that we don't have too many more webinars together. Give us a little break over the next month. But we enjoy talking to everybody, and along with helping other people learn, we're learning a lot of stuff on our own. So we really appreciate having this time to meet with everybody.
Thank you, everyone.
All right. Have a good one.